Here we're going to take a look at macromolecular structures, one of the 4 structures that we need to be aware of in the bonding section. Remember, we have looked at giant ionic, giant metallic, and macromolecular now is going to be mentioned in this video, and we'll also be looking later on at simple molecular structures. The first thing to be aware of is what type of bonding is involved in a macromolecular structure. Well, the bonding involved is covalent. And a macromolecular structure, macro means very, very big. Macromolecular structure simply involves a very, very big molecule where all the atoms are bonded covalently. And some examples of macromolecular structures include diamond and graphite, and they are both what we call allotropes of carbon. An allotrope is where you've got the same element but it's got a different structure. Another example would be silicon, and another one would be SiO2, silicon dioxide, which is the name for sand. What we're going to do in this video is we're going to look at the structures of diamond and graphite and see how we can use the structure to explain some physical properties. The first we're going to have a look at is diamond. And what we can see with diamond is that each carbon atom is bonded to 4 other carbons. And we can see that if we look at the structure of diamond. So we're going to have a look at, say, this carbon here. And we can see that this carbon that I've circled is bonded, to 4 other carbon atoms. Now, the physical properties we need to look at is, firstly, the melting point. And the melting point is very high, or melting and boiling points, I should say, are very high. Again, if you've got the word high in there, we should have the word somewhere. If we're able to ask to explain why it's got a high melting point, we need to put the word strong in. And why is it got a high melting point, very high melting point? As many strong, I said the word strong, covalent bonds need to be broken. And then we would tag on the end of it, requiring a lot of energy. So that is the first physical property. These covalent bonds, there's lots and lots of these. We've got to break all these covalent bonds to boil or melt diamond, and because we've got so many, lots and lots of these strong covalent bonds need to be broken, it's going to require a lot of energy to melt or boil these. It's also got what we call a very rigid tetrahedral structure, and that makes diamond very, very hard. The word tetrahedral is something that we'll look at when we do shapes of molecules. So another property, it's got a rigid tetrahedral structure with strong covalent bonds, and that makes diamond very hard. It's actually the hardest known substance on the planet, and that's due to a rigid tetrahedral structure with strong covalent bonds. The other property that we need to be aware of with diamond is the conductivity, and it does not conduct electricity. And That is because there are no delocalized electrons. We could say then that all the electrons are involved in bonding. So each carbon atom's got 4 electrons. And if we have a little look there, that each of these carbon atoms, 1, 2, 3, 4. So we're looking at the green carbon, all 4 of this carbon that's circled in green, all 4 of its outer electrons are involved in bonding, therefore no delocalized electrons, and therefore it cannot conduct electricity. The next macromolecular structure we're going to have a look at then is graphite. And in graphite, what we have here now is that each, which is different to diamond, is now each carbon atom is bonded to 3 other carbon atoms. And again, if we just have a look at the diagram of graphite, this is the structure of graphite. And let's just pick, for example, this carbon here. We can see that we've got it bonded to 1, 2, 3 other carbon atoms. We can see with graphite, they're arranged in layers. And this here, for example, is one layer, which I'll just call layer 1. And this here is another layer, which I'll just call layer 2. And there are weak forces between the layers. Let's have a look at some of the properties now. Now, the first thing to have a look at is the melting point, and it again is very high. Melting and boiling points, very high. And the explanation for that is exactly the same as that of diamond. So I'll just put there C, diamond. We have a look at diamond. As many strong covalent bonds need to be broken, requiring a lot of energy. It's just the same for graphite. Graphite is not a very hard substance. In fact, it's soft and slippery. And that's due to the weak forces between the layers. Weak forces between the layers and the weak forces between the layers mean that if a force is applied, the layers can slide over each other easily. So if we apply a force, for example, in this direction, then these layers can just slide over each other due to the weak forces between the layers. And that makes it soft and slippery. Instead of being very hard, you see it's soft and slippery, and actually is a very good lubricant. Now, the last thing to look at then is does it conduct electricity? And it does conduct electricity. Because, as we've said, each carbon atom has bonded to 3 other carbon atoms. So if you just have a look at this carbon that's circled in green, 3 electrons there used in bonding, and its 4th electron then is delocalized between the layers. So it does conduct electricity, as there are delocalized electrons. Okay, so there are delocalized electrons. Again, you may be able to have to explain why. If you were asked to explain why, it's because you'd say each carbon atom is bonded to 3 others. That is, each carbon atom uses 3 electrons in bonding, and each carbon atom then has 1 electron then, which is delocalized throughout the structure. Now, I would say that silicon, we've mentioned here, silicon and sand, they have very similar properties to diamond. So I would say Si and SiO2, they have similar structures and properties to diamond. Don't quite have as higher melting and boiling points, but they are similar. They still have high melting points, and again, neither of those conduct electricity because they have no delocalized electrons. So that's some information there about macromolecular structures. Quite easy to learn these facts, so should be ideally easy marks if these come up in the exam.